We showed in graphs 9.1 through 9.3 how we can derive demand curves for consumers from the consumer diagram when consumption goods are what's on the axes. Then in 9.4 we showed that we can also derive labor supply curves from the consumer diagram if we just put leisure and consumption on the axes. We'll now illustrate how a supply curve for capital can also emerge from the consumer diagram when the budget is an intertemporal budget and we analyze the savings decisions of people who choose whether to consume now or in the future. Since it's reasonable to assume that consumption is always a normal good, we'll restrict ourselves to cases where consumption now and consumption in the future is in fact a normal good. To focus on the decisions of savers, we'll return to the example of you earning $10,000 now and deciding whether to consume all of it now or whether to save some of it for future consumption, where the interest rate between now and the future is 10%. You therefore have an endowment bundle of $10,000 of current consumption, where current consumption is measured on the horizontal axis as C1. If you saved all that $10,000, you'd have $11,000 for future consumption, denoted as C2 on the vertical axis. Your initial budget constraint is then formed by connecting these vertical and horizontal intercepts, and we'll assume that your optimal decision under these circumstances is to consume bundle A, which is to say, you'll consume $5,000 now, save the rest, and have $5,500 available for future consumption. Now suppose the interest rate goes to 20% over this period, allowing you to save enough to consume as much as $12,000 in the future if you consume nothing now. This gives us the magenta budget constraint, and suppose that bundle C is your optimal consumption bundle on that constraint. We can then isolate the substitution effect by drawing in our compensated budget constraint, which is the final budget constraint moved inward until it is tangent to the original indifference curve at bundle B. Notice that in going from point B to C, and thus from the green compensated budget to the parallel magenta final budget, both consumption now and consumption in the future increase. Thus, consumption now and in the future are normal goods. The substitution effect recognizes that the opportunity cost of consuming now has increased when the interest rate went up, and as a result it points us in the direction of consuming less now and more in the future. The wealth effect, on the other hand, pushes us in the other direction, towards more consumption now. This is because a decrease in the interest rate makes us feel richer, and as a result we want to consume more of all goods, including current consumption. In the case we've drawn here, the wealth effect is larger than the substitution effect, and therefore outweighs it, because we've drawn bundle C to the right of bundle A. The amount that we save now is by definition the difference between what we earn now and what we consume now. At bundle C, we consume more than $5,000, we earn $10,000, and the amount that we save is indicated by the magenta bracket. This compares to our original savings of $5,000 at bundle A. We can illustrate our $5,000 of savings at the initial 10% interest rate on the lower graph by putting savings on the horizontal axis and the interest rate on the vertical. At an interest rate of 0.1 or 10%, we're saving $5,000. It looks like bundle A is simply dropping down to the lower graph as point A, but that's only because we're dealing with a very special case. In the top graph, we're measuring consumption now on the horizontal axis. Consumption now is $5,000 at point A. But since our income is $10,000, our savings is $10,000 minus $5,000, which is also equal to $5,000. Thus, when we measure savings on the horizontal axis in the lower graph, we also get $5,000 of savings. In other words, the $5,000 indicated on the horizontal axis in the top graph indicates $5,000 worth of consumption. The $5,000 indicated on the horizontal axis in the lower graph indicates $5,000 of savings. At bundle C in the top graph, we're consuming more than $5,000 now, which implies that we're saving less than $5,000. This implies further that when we drop bundle C to the lower graph, it has to switch sides, because on the lower graph we're measuring savings and not consumption. At bundle C, we're saving less than $5,000, which implies that C will lie to the left of A when savings appears on the horizontal axis. C also happens at the higher interest rate, so it has to occur at the higher 0.2 level on the lower graph. Bundle B, on the other hand, occurs to the left of A in the top graph and indicates less current consumption than $5,000. This implies that at bundle B, savings would be greater than $5,000, and so bundle B also has to switch sides relative to bundle A when we transfer it to the lower graph where we measure savings on the horizontal axis. B furthermore occurs on a budget constraint that has the same slope as the final magenta budget constraint, and thus the same interest rate. Thus bundle B has to appear at the same level as C in the lower graph. To emphasize what we've done further, we can take the bracketed magenta distance in the top graph, the distance that indicates our savings at bundle C, and show where it happens on the lower graph. In the lower graph, we're measuring savings, and so the magenta bracket occurs from 0 to bundle C on the horizontal axis. If we then connect bundles C and A, we illustrate how the consumer's savings behavior changes as the interest rate rises. In this case, as the interest rate rises, the saver saves less. This curve is also this saver's supply curve for capital, because when a saver saves, he's supplying capital to the market. As always in this chapter, we're using bundles A and C, which are the bundles that indicate actual change in behavior, rather than bundle B, which is a hypothetical bundle that is used simply to illustrate the substitution in the wealth effect. In panel B, we'll start exactly as we did in panel A, assuming a current endowment of $10,000 that can be saved at an interest rate of 10% for future consumption. We'll assume that the original optimal bundle is again bundle A, $5,000 current consumption and $5,500 worth of future consumption. The only difference is that we'll assume that when the interest rate increases, and we therefore land on the magenta budget constraint, point C now moves to the left of point A. When we then introduce the compensated budget, we get exactly the same substitution effect as we got in panel A, because we've assumed the same shape for the indifference curve that goes through bundle A. We're still assuming that consumption now, as well as consumption in the future, is a normal good, and so the wealth effect is still pointing in the opposite direction as the substitution effect, just as it did in panel A. But by moving bundle C to the left of bundle A, we've made that wealth effect smaller, and so it no longer outweighs the substitution effect as it had in panel A. This implies that as we go from A to C, we're going to decrease our consumption and thus save more. The bracketed distance that indicates savings at bundle C is therefore now larger than $5,000, not smaller as it had been in panel A. Just as we did in panel A, we can then again transfer the information contained in points A and C on the top graph to the lower graph where we now measure savings on the horizontal axis. Point A lies right below the A point in the top graph simply because our consumption initially was $5,000, as was our savings. Point C will switch sides, because now we're consuming less, which means we're saving more. Point B will translate exactly as it did in panel A, because the substitution effect is exactly the same as it was in panel A. And the bracket indicating the savings that we undertake at bundle C in the top graph also translates to the lower graph, but it now is larger because point C now lies to the right of A, whereas previously it was to the left of A. When we now connect points A and C, we get an upward sloping relationship between the interest rate and the amount of savings undertaken by this individual. In other words, we get an upward sloping supply curve for capital. Since we've assumed throughout in both of our graphs that consumption is always a normal good, the ambiguity about the slope of the supply curve for capital has nothing to do with any assumption about whether consumption is normal or inferior. Rather, the ambiguity emerges because we don't know whether the substitution effect is larger or smaller than the wealth effect, and the two effects will point in opposite directions if consumption is in fact a normal good this period. The substitution effect says savings will increase as the interest rate increases. The wealth effect says the opposite. We can therefore conclude the following. If consumption now and consumption in the future are relatively complementary, then we would expect relatively small substitution effects that should be dominated by wealth effects, and as a result an increase in the interest rate will lead to a reduction in savings. If, on the other hand, consumption now and consumption in the future are relatively substitutable, we would expect large substitution effects that are not overwhelmed by the wealth effect, and as a result an increase in the interest rate will lead to an increase in savings.